Okay, in this video, we will talk more about nth roots and how it's related to the absolute value. So recall that if n is a positive integer, then this symbol, like this, means the nth root of a. And some clarification about that, when n is even, this is the nth root of a means the non-negative value whose nth power is a. When n is odd, then there's only one value whose nth power is a. There's only one real number that has that property. So it's the value whose nth power is a. And throughout all of this, I'm only working with real numbers, not complex numbers. And also one thing to remind you of is that the square root of a is when n is equal to 2. Because it's the number whose second power, right, that's squared, is equal to a. Oh, 1 second. Okay. So, for example, the square root of 16 is 4. And because 4 squared is 16, and 4 is positive. If I have negative 4, and I square it, and then take the square root, well, negative 4 quantity squared is negative 4 times negative 4, which is 16. And we just saw that the square root of 16 is 4. Notice that it's not negative 4. If you want to write it as negative something, it's negative 4. It's negative 1 times negative 4. Similarly, if you have negative 5 and then square it and take the square root, this is the square root of 25 because negative 5 quantity squared is 25. The square root of 25 is 5. And I just want to emphasize that it's not negative 5. What about the fourth root of 16? That is equal to 2 because we are looking for the non-negative value whose fourth power is 16, and that's 2, not 2 or negative 2. So you might think that it's 2 or negative 2. Now it's true that negative 2 raised to the fourth power is 16. But when we say the fourth root of 16, we mean the non-negative one. So that's why the answer is just 2. So just to emphasize that, if you take negative 2, raise it to the fourth power, and then take the fourth root, that's going to be the fourth root of 16, which is 2. And if you want to write it as negative 1 times something, it's negative 2. This is only an issue when the root is even. So if I had the cube root of negative 1 cubed, well, negative 1 cubed is negative 1 times negative 1 times negative 1. That's just negative 1. And the cube root of negative 1 is negative 1. So when you have an odd root and an odd power, those actually do undo each other. So if you have negative 5 cubed and then the cube root, negative 5 quantity cubed is negative 125. The cube root of that is negative 5. And of course, there's no issue if you have positive input. So if you do 1 cubed and then take the cube root, you just get 1. If you take 5 cubed and then take the cube root, that's the cube root of 125, and that's 5. So let's summarize what we have seen. If n is odd, then if you take any number and raise it to the nth power and then take the nth root, that is equal to a. There's no problem with that. But if n is even, then it's not that simple. It's slightly more complicated. Then the nth root of a to the n, what you get depends on whether a is positive or negative. Now if a is positive, or if a is 0, then you're just going to get a as a result. So it's a if a is greater than or equal to 0. However, if a is negative, okay, what did we see? If a is negative, then when you square it, you get something positive, and then when you take the square root, you get something positive. However, the result is not completely unrelated. Like if you plugged in -4 into the function where you square and take the square root, you end up with +4. And that's -1 times -4. Similarly, if you plugged in -5, you would get out +5. And in general, if you plug in a negative number a, you get -1 times a as a result, and that's -a. Now first, you might think that there's a mistake here because shouldn't it be the other way around? Well, no, because if a itself is negative, so just pretend something like a is -4. Okay, so for example, e.g., a is -4, then your -a would actually be +4. So it's actually correct. It takes a bit of getting used to. So that's what's going on. So people will tend to say that squaring and taking the square root undo each other. That's true if the input is positive, but when it's negative, the result actually flips the sign from negative to positive. Now, can you think of a function? This might look familiar to you. Something that's a if a is greater than or equal to 0, and negative a if a is negative. Notice, I'll give you a hint, it's part of the title. It's the absolute value. If you have the absolute value of a, that is also equal to a if a is greater than or equal to 0, and negative a if a is negative. Let's just review why that's true. Because if you have the number line, so here's the number line, here's 0, if a is positive, like here, then this distance from 0 to a, that is by definition the absolute value of a, is just equal to a. On the other hand, if you have a is negative, then this distance, which is the absolute value of a, is equal to -1 times a. So for instance, if a was -4, then the distance from -4 to 0 is -4, which is +4. So what have we discovered? We've discovered that the nth root of a to the n is given by a if a is greater than or equal to 0, and negative a if a is negative, but the absolute value of a is given by the same function. So what that means is that these are the same. So let's write that down. So the conclusion is that if n is even, then the nth root of a to the n is just equal to the absolute value of a. For example, let's say that x is a number and you want to simplify the square root of x plus 6 quantity squared. This is going to be the absolute value of x plus 6. Remember, what I'm doing is I'm thinking of x plus 6 as like a blob. It's just some number. You might call it u. If I have the square root of u squared, that's just the absolute value of u. So in this case, I have the absolute value of x plus 6. Similarly, if I have the square root of x squared minus 4x plus 4, what can I do? How can I write the inside? Do you recognize what I can do? The inside is a perfect square. It's equal to x minus 2 in parentheses squared. Now I have that same pattern where I'm squaring and then taking the square root. That's going to be the absolute value. So I'm left with the absolute value of x minus 2. Let's do a few more examples. The fourth root of y squared minus 6 raised to the fourth power. So this is, I'm taking y squared minus 6, I'm raising that to the fourth power, and I'm taking the fourth root of that. That is going to be the absolute value of y squared minus 6. What if I had the fourth root of y squared plus 1 raised to the fourth power? Well, that's going to be the absolute value of y squared plus 1. Now here, y is a real number. Can you simplify the absolute value of y squared plus 1 a bit more? In this case you can, because y squared plus 1, if you think about it, that's always going to be positive, because when you take a real number and square it, it's always at least 0. So if you add 1 to that, you're always at least 1. What that means is y squared plus 1 is always positive. And so the absolute value doesn't do anything, so it's just y squared plus 1. Or you could even just have the absolute value of y squared. That would still be y squared. Or if you had the absolute value of y squared plus any positive number will just be y squared plus that positive number. Okay. Let's do one more example. Simplify the square root of 64y squared. Now notice that here I have a product inside the square root. It's 64 times y squared. And y squared, what can I say about y squared? It's greater than or equal to 0. And if you have two numbers that are greater than or equal to 0, one of the properties of square roots is that you can split up the square root. So it's the square root of 64 times the square root of y squared. And the square root of 64 is 8. The square root of y squared is the absolute value of y. So that's the simplified form. What happens if you take the square root and then square it? Well, here we're working with real numbers. So in order to even take the square root, your number has to be non-negative anyway. So you don't have this issue with negative numbers. So if you have the square root of y and then you square it, that's just going to be equal to y, as long as y is greater than or equal to 0. If y is negative, then it's still true, but you're going to have complex numbers. So if y is negative, like, let's say that y is negative u, okay? Then the square root of y is the square root of negative u, which is going to be I times the square root of u. And then when you take the square root of y and square it, that's going to be I times the square root of u squared. That's I squared times the square root of u squared. I squared is negative 1. Square root of u squared is u, so you get negative u, which is equal to y. So it's still true, but you have to throw in complex numbers to make sense of the square root of a negative number. Okay, so still true that the square root of y squared is equal to y as long as you work with complex numbers. So if you were taking a class where you didn't talk about complex numbers, then they wouldn't be the same because one side would not exist. Okay, so that's what I wanted to say in this video.